When constructing interval estimates for a population proportion, the general form is pretty similar to constructing interval estimates for a population mean. That is, the sample proportion p bar plus or minus some margin of error will be consistent with us being some percent confident that the true proportion will be within that interval. Now, again, the important point, as you will recall from chapter 7, is that when two criteria are fulfilled, then we can use the normal distribution. And these are the two criteria: n times p being greater than or equal to 5, and n times 1 minus p being greater than or equal to 5. The picture is analogous to the population and the sample means. We determine alpha, which determines our 1 minus alpha, and we will then determine what the critical z's are that are consistent with our degree of confidence. And this is the formula. It does look very much like the formula for the interval estimates for the sample mean, right? So here we have the sample proportion p bar plus or minus the critical z times the square root of p bar times 1 minus p bar all over n. So let's consider this example. There is a political pollster which is using telephone surveys. They have found that 220 out of 500 voters contacted favor a particular candidate. PSI now wants to develop a 95% confidence interval. So this is the formula. We know that n equals 500. We know that p bar is 220 over 500, or 0.44. For 95% confidence, remember that the critical z is 1.96. So we plug in all those numbers, and we get this interval estimate. We can be 95% confident that the proportion of all voters that favor the candidate is between 0.3965 and 0.4835. As with the population mean, there is also an analogous formula for computing the margin of error, and from that, solving for the necessary sample size. However, the key point here is that we do not know p bar until after we have selected the sample size. Because remember, right, we first decide on the sample size here, we sample the people, and then we get p bar. So we will have to use the planning value p star. How do we use p star? There are several choices here, but I would prefer that you use choice 4. Use 0.5 as the p star value, because that is the most conservative choice, because that will lead to the largest sample size, and we do want to have a large sample size so that our results can give us more confidence. So here, they would like a 99% probability that the sample proportion is within plus or minus 0.03. So how large should the sample size be? Now in this case, they use the previous information that they had gotten 0.44. So let's try this out. Plugging in all the numbers into the equation, we will get n equals 1,817. Hence, to be 99% confident that the sample proportion plus or minus 0.03 will contain the population proportion, we need to interview 1,817 people. But as I noted, it's probably better to use 0.5, because then that way it's the most conservative choice and will require you to go for the largest sample size possible. In this case, the n would have been 1,843 compared to 1,817.